You've likely heard the warning that machines are coming for our jobs. Economists have long dismissed this anxiety as a misunderstanding of how technology works. This diagram illustrates their defense, the expanding pie theory. Traditional consensus argues that while technology replaces tasks, it boosts overall productivity. This creates a larger economic pie, generating societal wealth. When tasks are automated, the worker isn't eliminated. Instead, their effort is reallocated. Take the introduction of ATMs. Initially, people panicked that cash dispensing machines would render bank tellers obsolete. But over 30 years, as ATMs quadrupled, bank tellers increased by 20%. Free from counting bills, tellers moved into advisory roles, expanding branch services. Historically, this dynamic protected both highly educated specialists and lower-skilled manual laborers. But that safety net is currently failing the middle class. Jobs occupied by secretaries, salespeople, and administrators are steadily declining. Economists used to draw a strict line to explain this. They theorized that routine work, tasks that could be broken down into repeatable steps, was vulnerable to machines. Conversely, non-routine work involving creativity, judgment, and complex interpersonal skills was considered permanently safe from automation. As AI evolves, the barrier between routine and non-routine is disappearing. Machines now perform tasks requiring creativity and judgment once thought unprogrammable. The idea that human creativity and judgment offer a permanent shield is an illusion. The global workforce is now entirely exposed to a level of automation that does not play by the old economic rules. Our fascination with self-operating machines dates back to antiquity. The ancient Greek poet Homer even imagined driverless three-legged stools in the Iliad. When real progress began in the mid-20th century, engineers tried to build these systems by directly mimicking human thought. They pored over the insights of experts, trying to map out a human logic tree in code. By the late 1980s, this approach hit a wall. Human intuition proved too complex to manually program. This diagram shows the turning point. Researchers abandoned the logic tree and embraced pragmatic AI. Instead of trying to imitate how humans think, engineers built software that could analyze vast amounts of data to find its own, completely unconventional solutions. The world saw the power of this pragmatic approach in 1997 when IBM's Deep Blue defeated world chess champion Garry Kasparov. The machine didn't win by thinking like a human grandmaster. It won by processing millions of potential moves per second, identifying underlying patterns that entirely defied human understanding. By dropping the requirement that machines process information the way we do, AI crossed a critical threshold. It proved capable of acquiring complex, non-routine skills, shifting tasks once thought to require human intuition firmly into the machine's domain. Today, AI is executing tasks we thought were exclusively human. Chinese tech firms use systems trained on hundreds of millions of records to evaluate medical patients. Facial recognition algorithms can now distinguish a genuine smile from a fake one with greater accuracy than the human eye. These systems are aggressively infiltrating complex physical industries. In Japan, autonomous drones have effectively taken over the agricultural crop spraying market, executing tasks that require precision and fine motor control. But this technological takeover isn't happening uniformly. Japan's aging population and labor shortages create a massive incentive to automate. In countries with younger populations and lower wages, businesses have less immediate financial pressure to replace human workers. As science fiction author William Gibson observed, "The future is here. It's just not evenly distributed." This uneven distribution creates severe frictions. As old jobs vanish, a displaced factory worker cannot seamlessly pivot to managing AI systems, nor can they easily relocate to the concentrated geographical tech hubs where the new wealth is generated. While some regions adopt these systems slower than others, the global trajectory is clear. As machines approach autonomy, productivity will skyrocket, and the overall demand for human labor will simply relentlessly decline. For centuries, human survival has been tied to selling our skills and abilities, our human capital, for wages. When machines automate those skills, that capital loses its value, leading directly to structural, extreme inequality. This line graph maps out the fracture point. Before 1980, income growth across different economic classes tracked upward together. As the economy grew, both lower earners and the wealthy saw steady wage increases. But watch what happens as the timeline crosses 1980. The wages for lower earners flatline. Meanwhile, the income for the wealthiest 1% spikes violently upward. Wealth consolidates into the hands of those who own the technology, rather than those who perform the labor. The modern welfare state was designed on the assumption that a massive, fully employed human workforce will pay the taxes required to support the unemployed. But if the labor market no longer provides those jobs, the mechanism that distributes wealth from the top to the bottom stops working. This shift moves the responsibility for wealth distribution from the market to the institution, the big state. In a world with less work, the state must take a more central role, taxing the primary beneficiaries of automation, tech companies and capital owners, to fund the survival of those whose human capital is no longer in demand. To maintain social harmony, this wealth should be redistributed through conditional basic income. Unlike a universal check, this system targets support towards specific communities and ties it to certain criteria. This addresses the perceived unfairness of blanket payments, allowing society to support its members while fostering collective stability. We have reached a point where technology produces more than enough for everyone. If we can use the big state to decouple human survival from the 9-to-5 job, we can build a society where machines finally free us to live stable, supported lives.